Our next speaker is Tom Van Tilburg from Geodan. We're going to bring him over online here. I should point out that we have a few helpers from Crunchy Data Online. You'll be seeing Elizabeth all day long, who's running things behind the scene, bringing our new panelists on and cycling through our speakers. We may or may not hear from her as the day goes on. Adam Tim is with us. I believe Michelle Emmanuel is with us, and we may not see them helping out as question wranglers. Let's get Tom set up.
Hi, I think I'm there.
Hey, I hear you, Tom. Welcome.
Thanks. How'd you do?
I do great. It's lovely to have you here here in PostGIS Day. And since I have you for a few minutes while you click around and get things set up, I wonder if you could tell me like when and why did you first start using PostGIS? What was your PostGIS journey like?
Oh goodness, that's back in the day. We got university times where I had to publish a small map with just a couple of points. It was research on some, I think, ice wedges somewhere in Siberia that we had to post on a map. And the things at that moment available to post things on the map was not very interactive. So we were looking at map server. And the only thing those days that worked well with map server was PostGIS. And I think it was definitely below version 1.
Oh, wow. A 0.9 PostGIS user. That's great.
Yeah, for sure. And yeah, since then, haven't looked around.
Well, I think you made the right choice. Well, thanks for joining us, Tom. Fire up your screen share.
Yeah,
and Tom's going to be talking to us about delivering a national level vector tile map using PostGIS and pgtileserv, talking us through the whole process from data production to web publishing. So yeah, take it away, Tom.
Thanks. I hope you can see my screen. Is that correct?
Yep, looking good.
Great. My apologies if I sound a bit hollow here. I just moved houses and it's still a quite empty room. I should have putting up some pieces of clothing or something, but I noticed there's a little bit of echo here, so apologies. So I'm going to read this title once out loud. It's very long and it's for a reason. It is how to make a vector tile base map using PostGIS and pgtileserv. It goes from data production to web publishing. Now, of course, if you have a talk for PostGIS Day, you have to put in the right words in your title. So that's the first thing to do. Last year, I put in why not to use PostGIS. For some reason, that never got through. So this year, I'm lucky. But of course, the title really says something about what I'm going to show you. It's basically a cookbook. So I'll take you on a journey that we had, so going from raw data into publishing a web map. And I'll just take you along in the steps. And if I click, I hope I go to the next one. Yeah, there we go. Now, what situation do we start from this journey? We are with a demand. As a company, we're doing maps for a long time. But there is a couple of demands in the meantime that would force us off the beaten track. Basically, we always did GeoServer and then TMS, that kind of stuff. But we wanted a nice looking base map, preferably vector-based instead of raster. And secondly, we wanted to be able to switch between multiple themes or stylings, if you wish. On top of that, we know that part of our base data is going to be updated once a week. And once a week is often if you talk about the national level map. So you can't really spend all your time on keep retiling that in a raster set. And since we are a respectable company, of course, we have to adhere to some standards. So obviously, there's not a lot you can choose through. And not unimportant, all of the data that we have is already in PostGIS. So what can we do then? Well, rasters, obviously, we can't hang on for a long time. Can't we deliver a vector? Yes. Probably, and we only have one serious option, which is basically vector tiles. GeoServer can do vector tiles, but it's also a bit bulky. It runs on Java. It takes a non-trivial amount of resources. Before you fire up GeoServer, you have to fire up a couple of other things. And also, we already did some early experiments with the vector tile function in PostGIS, which gave us very promising results at that time. And then we're talking a couple of years ago, of course. So this leaves us then with a couple of options. For instance, Tegola, which has been around for quite some time, but also Martin and Postal are good services. There was some contemporary work though that stood out though because of the simplicity of it, which happens to be pgtileserv. And it mainly was attractive to us because it was the thinnest layer possible at the time. There's not much needed to deploy it, and you're very close to the database. And being very close to the database is nice because you can do a lot with that. It also improves the chance that you get a spot on the presentation day, so that's nice. But first, a little bit background in where I come from. I come from the land of tulips and windmills, the Netherlands. In the Netherlands, there's a tendency to have an asset management of the whole landscape. They're rather thorough in this. So anything in the public domain has a name and a place. So the roads, the canals, the grassy fields, every tree, every windmill, and of course the flower fields are mapped. And the database with all these assets, it's a single database, is called de basisregistratie grootschalige topografie. I just wanted to pronounce it in Dutch because it sounds great, I think. But it roughly translates as the base registration of large-scale topography. And all assets have a location as a point, a line or a polygon, where I should note that the whole country is covered without gaps in the polygons. So if you plot the map, you should not see any gap in between for the whole country. And in this picture, as you can see, there's quite a handbook with rules on how to create these objects. People really go into the field and map this. It's pretty precise. And every landscape element in the public domain has its own category. You can imagine that's a lot of categories to cover. And if you look on the picture, the purple rings, every purple ring is one tree, for instance. As you can imagine, this data set is rich and maybe a little bit too rich if all you want to see is the outline of the city in your base map. And therefore, there's luckily another nationwide dataset available, which is called the basisregistratie topografie, almost the same as the previous one, but slightly simpler. Now, this dataset has less details than the previous one, and it's more suitable for mapping on a, let's say, 1 to 10,000 scale. It's a standard dataset for the paper topographic maps in the Netherlands. As you can see, it makes decent maps. This is an example with a shared QGIS layer style, which you can use. So you just throw in the data, add the style, and this is what you get. And these are very decent maps already. On top of it, I should mention another one, which is actually European-wide. This is the Corinne land cover dataset. This is based on satellite data. And you can see it is pretty coarse, but you can also imagine once you start zooming out and you get a view of the whole country as one piece, it doesn't matter that much that it's so coarse. It's mainly the coloring that matters because these colors are still horrible, of course. I'll show you later how we used it. Now, obviously, we're going to use these different data sets as separate levels of detail for different zoom levels in our base map. So we don't have to do some massive simplification or spend a lot of time on thinking what we do with the smaller roads and put them together into one or not. That's already thought out for us. So to give you an idea of how that works out, this is the most detailed level. Then we go to a slightly simplified one, and then big jump to one more level. So this is the 1 to 10,000 level, and one more big jump to the Corinne gives you this, which is obviously not suitable for this zoom level, but you'll see later on how it works out. So all in all, we have over 35 million of polygons in our database, and we can use them as a base map. We do need to do some work still, because as you can see, there's quite a big difference between this map and this map. I will leave out Corinne because it's a different matter here, because this is a part of Amsterdam. You see 2 canals here, and in the most detailed one, you see even the parking places along the water. And one step lower, you see basically just canals, roads, and something else. So we could use an intermediate level, and that is what I'm going to show you now. We started working on dealing with this 32 million polygons to make it a little bit more smooth to run in a database before we start handing out vector tiles. Step one, we have to reclassify because there's over 80 classes in this data set. That's a lot. That's a bit too much for showing on the base map. And the chances are that you will only distract the viewer if you put too many classes in there. So we brought these down to 13 classes. And I'm sorry, this is all in Dutch, but to give you a little idea, it makes a difference between either something you can ride with a horse or only with a bike or only on foot. But for a base map, you might argue that these are one and the same kind of coverage. So we go down to 30 levels. That is nice because we can also compare them better to the Korean dataset, for instance. Another step is merge the data. As you can see on the left, every building has its own polygon, but we're not going to show every building as a separate entity on the base map. We're just going to show a bunch of buildings. So why not just put them together with a union? And the same is for the parking places and the roads. We can also do them together. So what you see happening here from the left is simply a union on all the geometries, and that gives you a big blob of houses together. There is one thing to keep in mind there. There's one caveat. If you do this for a lot of houses or a lot of water, especially water tends to have a problem with this, you are going to make really, really big polygons. So therefore, you can see in the little code sample here on the top right, there's also this subdivide option, which I'll come back to later, which is utterly important if you start doing this. Oh, and that also explains these black lines you see in the middle, if somebody might wonder. One more step, we want to simplify. Vector tiles themselves already do simplification, but we want to help that a bit. We want to pre-simplify some zoom levels, and therefore you have the option of a couple of algorithms in PostGIS. Actually two, standard simplify, which is I think using a Douglas Puker algorithm, then one did similar fashion, but it doesn't make invalid topologies, and simplify according to the Viswanningham-White. Now, all three of them are not good enough, and I'll show you why. Because if you do this on polygons, then this is what might happen. This is an example I took from somewhere. I think there's even a bug report somewhere having this image. The middle is what you want, but the right side is what you get with these algorithms. And it's just not good enough for simplification. Now, there are some tricks to do this with SQL itself, which are rather complex. We chose a different complex route, which I'm going to show you now. And what you see is we used JavaScript. I will not explain you how this exactly works. It uses topo.json, and that's the bottom line. And since the query is rather long, I go in 3 steps quickly to it. But the first step is you create a very big feature collection of your geometries. You make one big GeoJSON, you feed that to the next step, which is a wrapper around some JavaScript. You can actually run JavaScript from within Postgres, which is tends to be rather dark magic, but it works and it is pretty fast. So what you see here, what's happening is you first make a topo.json, which makes a kind of topological setup of all your polygons. You do run a simplify over it, and that simplify will make sure that all your borders will stay aligned. Some merging on top, you get that for free to merge some water bodies. And the last step you have to do is put all that JSON back into PostGIS geometries. Now, I should mention the first step by now got a little bit more easy because this, as far as I know, can be done with the STS GeoJSON function by itself. You don't need to build JSON objects anymore. So one more step we did, and I already said I was going to come back to this, the subdivide. Now, if you have lots of, for instance, water bodies, and in the Netherlands we have a lot of them, as you can see, geometries tend to be rather big and complex. Now, big and complex geometries are expensive if you just need to make small vector tiles for just one corner of your geometry, for instance. So that would be a waste of time if you let your processor calculate all the cutting out of these tiles. So why not already make smaller tiles for them? Now, if you use the subdivide function, this is roughly what you get. You can set a maximum number of vertices in your polygon, and they will be cut smaller from that point. And doing this step beforehand will help the vector tile function to cut quicker through your geometries. And in the end, you will not see anything from this in the base map. So the data is ready. Up to now, we've been doing reclassifying. We've been merging our data. We've been simplifying it. We've been subdividing it. And as a result, we have a lot of layers for several zoom levels. But now, how do we tell pgtileserv, which we're going to use, but up to now didn't do anything with, to deal with zoom levels? Because zoom levels is not a standard thing for pgtileserv. pgtileserv knows not much. It knows how to connect to the database and how to create a vector tile. So we have to help it a little. And luckily, there's a very nice feature there. And one of the biggest advantages here of pgtileserv is that you can very easily connect to a custom SQL function. If you write the function in a certain way, it will be picked up and it will be served as a vector tile. And this gives you flexibility. And I hope you don't get scared, but there's quite some code coming in here. This is basically the way that you build a piece of vector tile function. There's some standard wrapper around it. You need to give some boundaries. You write an MPT geometry function, and here you get flexibility in the middle to do whatever you like with it. In this case, it is not much. The magic is here on the right-hand side. You see the Z is between a Z min and Z max, which will be the zoom level, of course. And this will tell your function to pick only certain layers within the database. There is one big caveat about this function. Maybe some people already can see what goes wrong, because it tends to be horribly slow. It is really very, very slow. And that's because of the following reason. It is written in SQL. Now, SQL writes pretty clean code. It is very understandable, but they do not use the index, which is really a big issue. So therefore, a hint, please write all your functions in PGSQL. And as a bonus, you can use here also the bounding box intersection instead of the intersect function, because the MPT function will cut it out anyway. There's no need for an intersect function. You can just look for the bounding box, which makes it a tiny little bit faster. So we're ready to serve. We have a table, 60 million records in it. We can serve out vector tiles. We have pgtileserv running. Now we are ready to deploy. I myself am not a fan of Kubernetes, but I have some colleagues who were really fabulous with it. And they told me that deploying this on Kubernetes is really the logical thing to do. So we went along, and what you see here basically is an Helm chart. And what this does, it deploys your tileserv to a Kubernetes cluster. And this is flexible because you can deploy as many as you like with as many resources as you like. Now you recognize a couple of things. There's a standard image that we use. It runs on a certain port. It connects to a certain database. Two important things to notice. One, it uses relatively small amount of memory. We think that can even be less, but this seems like a proper default. Another one is it was for us better to set the maximum features per tile to a negative, which means there is no maximum, because you might sometimes find out that you just miss a couple of features in your view, which is a shame. So where are we now? We are with the following architecture, which is really, really simple. On the simplest way, you just have the PostGIS database where every week you load your new data. And on top of that, you have pgtileserv. pgtileserv itself, if you request data from it, will, every time you request data, query the database. And that might give some load if you have a lot of concurrent users. Therefore, it might be wise to build a small cache in front of it, which we did. Performance difference is not that big, which I'll show you. But we did one more thing, because some people still do want good old TMS, WMS, or other OGC standards, which is why we put a maptiler WMS service on top of it, or TMS service. And I'm going to show you how that works out. Let me first start with our cached version, and I hope this works. Yes, this seems smooth. So, ta-da, this is the base map. Now what I'm going to do is zoom a little bit in, and what you see is the highest level of detail here. Now, remember, I reclassified a lot. There's a lot more data in here that might be seen, but not shown because the colors are basically just the same. And if we start zooming out, you'll start seeing some jumps to a new zoom level. First, you see simplification, and here we go to a new one, although it's hardly noticeable. And then there will be a bigger jump. Oh, and here we jump to the Korean data set. I have to say the labels come from somewhere else. The labels are from OpenStreetMap. So as you see, the performance is not bad at all. And this is with the cache. If you zoom in more, though, the cache will probably be empty. So the cache will be filled on demand. So as soon as you zoom there, you have new cache. As I told, one thing we wanted is restyling, which is possible. And this goes very smoothly. You can just press the button and it restyles on the fly. So this is a major improvement for us on top of the speed. And now to show, I want to show you what happens if you use the, and I just log out. I hope nobody sees my password. This is the same thing, but then the WMS service on top of it. And you see there is a difference in how it looks like. This is old fashioned. It shows a bit pixelated sometimes. But the nice thing is if you do it this way, the colorization will be exactly the same. The look and feel are the same. And now the no cache demonstration, which is the most exciting because you'll see that the speed of this is not much different from the speed we just saw. So this means the performance of pgtileserv is really pretty fast, or we should say actually the performance of PostGIS, because that's in the end the backend running this. There's one thing though, if you start zooming out, you see the whole thing will start slowing down. And this is the main issue, that we put still a cache in front of it, because this is basically too slow. Click, close it. So a little side step, there's no need to stay flat with your data. You can also serve vector tiles with a little bit of height data in it. Basically, it's an attribute. And the nice thing about this, you can hover over it and it right away gives you the metadata, all the properties of the buildings in this case. It's the building year and the height of it. And I think this is a pretty strong argument to start using this kind of way of serving your data. And the real reason we wanted to do this, and that is what I'm going to show now, is that we needed this base map to put something on top of it. And what we wanted to put on top, and this will be a little bit slower than before, is a bit more three-dimensional data. That's what you see happening here. So the combination of a very crisp base layer plus the 3D data on top of it makes it very usable for larger scale 3D maps. So basically, this serves now a 3D map of the whole country. And you see this was apparently the end. It still works. And the idea that you can now still click on your base map and get information on it, you can change the colors of it, is very powerful for us. Now, we're coming to the end. So that comes to some conclusions. Now, conclusions are always hard to make if you just made a journey with the cookbook. But I can say nothing else than we're quite positive about it. Managing your data within PostGIS like this is super easy because you can transform it at any moment you like. As soon as you pull in new data, you just run a couple of functions over it, and you have your base layer ready. pgtileserv has a very small footprint, which is exactly what we hoped for, which saves us in deployment. And performance, as you saw, is phenomenal. It goes, and I wrote phenomenal with the Dutch FIC, which is for us almost all we could wish for, because there's always something to wish, which I'd like to share in this sheet. Some things which came across our minds, which is also to do with the normal way vector tiles work anyway, is it would be nice if you can serve multiple projections. Currently, the standard is WebMarkator, which makes sense because the whole web mapping field is in WebMarkator, but it's not per se needed. It might be other projections as well, but it would be nice. One thing that would be really nice is if you can serve arrays of data in your attributes. How cool would it be if you can have a time series? So you have a slider in your viewer and all your colors of polygons change depending on your the time that you select, which would mean a little bit more data, but not that much. And JavaScript is very good in dealing with large arrays of data. So that would be a very powerful idea. And the last one, which we are really longing for, is to keep the Z coordinates. Why throw out the Z coordinate in your vector tile? Because how cool would it be if you go from this kind of view to this kind of, which in theory would be possible with vector tiles. And with that, I'd like to finalize my presentation. And I put a couple of links here, which is by far not extensive, but please click them because they have very interesting the information where I got my inspiration from. And for the rest, thank you so much for your attention.
Thank you very much, Tom. That was an amazing talk, and it's great to see pgtileserv being used in production. What is
like it?
Yeah. So you've got a few questions in the Q&A. Question from Malcolm Meyer. Does the performance of pgtileserv depend on the resources of the container running pgtileserv, the service running Postgres, both? Where are the bottlenecks?
Yeah, as the obvious questions. To be honest, we haven't pushed this in large scale production yet. So I'm very sure we're going to find some bottlenecks still to come. Plus, we are using the cache. Our default service is using a cache on top. We don't want to run any risk that we might have hit some corner where we get into trouble. That being said, you just saw the two differences between the cache-less and the cached version. So there is on the lowest levels not really a difference. If you go up, then you see there is a difference. Basically, I think because the geometries tend to get bigger, which eats more time from PostGIS or the STS-MVT function to cut through the geometries. And yeah, in the end, it will not scale forever horizontally, of course. There's a limit to that. So if you have a lot of concurrent users, I think there will be an end to that. You really need to go into caching and maybe even separate your data on different entries.
Yeah, the bottleneck is almost always on the database because that's where most of the CPU time is spent. Question from Martin Davis. Tom, what web map framework are you using to show the 3D view?
It is Mapbox, actually MapLibra, I should say.
Okay.
Yeah, but we put a little bit of salt on top of it to enable the addition of 3D tiles.
And a question for me, this 3D, so the extruded buildings, I understand how you did that, but the buildings with their pretty little A-frame roofs and so on, and the trees, like where are those coming from?
It is basically the same resource. The buildings we create ourselves. We have a point cloud set from the whole country, or a height raster, which enables you to kind of cut these buildings out of the raw data set with the right methodology. That is the most difficult part. The trees are also in a national data set. We know for roughly every tree how high it is and where it is, obviously. So we just replace that with standard models of trees. There's only 500. Yeah. Same goes for the cars, just parking places, you stuff them with cars and some street furniture, you know the location, so you just stuff in, you rotate it a little bit on the base of how the road runs, and then you use custom models. Okay,
and what format are the models?
GLTF.
Okay.
Yeah, if you make use of 3D tiles, which is an OGZ standard, then it's basically just follow the standard.
Yeah, nice. A question from Ilya Santos. How do you plug the pgtileserv output into MapTiler WMS?
Oh, I was hoping that question would not be asked because I didn't do it. I'll get back to it. He can definitely email me about that.
All right. I think that's it. If anyone has any more questions, put them in the Q&A. Tom, hopefully you can hang around for a little bit and watch the chat and watch the Q&A and see if anyone else has any more questions for you.